Hello everyone, welcome to Enviro Pioneers. In this video, we will try to understand the basic process of remote sensing. As we discussed in the last video, that remote sensing, it is the acquisition of information about the objects or our surrounding with the help of non-contact sensors. So, the sensors are simply the instrument which detect and quantify the amount of electromagnetic radiation reaching to them. Now, these sensors, it can be placed near to the surface or they can be placed in the airborne instrument or the satellite. So, remote sensing or the acquisition of information, it can be done from the various altitudes depending upon the type of information or the detail of information which is required. So, whether the information is acquired from the near surface or from the airborne instrument or from the sensors placed on the satellite, the basic process of the acquisition of information remains nearly the same. These images, they represent the basic process of collection of information. So, here we can see the sun, then we have the atmosphere, then interaction of electromagnetic radiation with target, then sensor, the data retrieval, storage, distribution, then we have the analysis and the application. So let us discuss this in detail. The first and very important thing is source of energy. So in general, we have the sun as the source of energy, but also we can place alternate source on the platform itself. Now the electromagnetic radiation from the source, when it propagates to the atmosphere, will be having the reflection, absorption and scattering in the atmosphere. So this interaction of electromagnetic radiation in the atmosphere, it is wavelength specific. It means कि particular wavelength will be scattered more या फिर कुछ कुछ wavelength जो है वो absorb हो जाएंगे या फिर कुछ जो है वो reflect हो जाएंगे. तो ये जो interaction atmosphere में हो रहा है, that will be always wavelength specific. Now, when this radiation, it reaches on the earth surface, that is referred as the interaction with the earth surface feature. Now we have the variety of objects on the earth और हर फीचर का जो कैरेक्टरिस्टिक है वो यूनिक होता है. यानी अगर हम अपने सराउंडिंग में प्लांट्स को इमेजिन करें या वाटर बॉडी को इमेजिन करें, सो यू मस्ट हैव ऑब्जर्व अ डिस्टिंक्ट कलर. मीन्स प्लांट्स वी ऑलवेज सी जनरली जो है दैट इज विजिबल to us with the naked eye in green color. जो water है वो हम blue color का देखते हैं. So the color which we are seeing, that is simply the wavelength which is getting reflected from those objects. तो अभी अगर हम यहाँ इस इमेज में देखें, we have different objects on the earth. The type of object on which this radiation is incident will be having the reflection or absorption. Absorption या reflection depend upon the albedo of that particular object. अगर albedo high है, so we'll be having more amount of reflection. But if the energy is absorbed by that object, it will be emitted in the form of long wave radiation. अभी ये जो reflected energy है या emitted energy है, that will be sensed by our sensor. अब ये sensors कौन से altitude पे placed हैं? If these are near to the surface और या फिर aerial based हैं या फिर satellite based हैं. So this part यहाँ पे जो हम देख रहे हैं, यानी कि जो reflected या emitted energy है, again they have to pass through the atmosphere. So there is possibility कि ये जो energy है, it may or may not reach to the sensor depending upon कि कितने amount में ये emit हो रही है या reflect हो रही है और कौन से wavelength में हो रही है. So the atmospheric component, they play very important role in determining कि कौन सा electromagnetic radiation कितने altitude तक reach करेगा. Now the sensors which are placed at different altitude, they are wavelength specific. Means some will be sensitive for the blue wavelength range या फिर green या red या NIR. So उनको किस wavelength range के लिए डिजाइन किया गया है, accordingly they will detect the amount of radiation reaching to them in that particular wavelength range, and these data are electronically stored. if these platforms are near to the ground or aerial based, तो collection of data easy है. But if it is satellite based, तो जो data store हो रहा है, that should be collected periodically. So we have the data retrieval, storage and distribution. So the data which is stored by the sensors on the platform is received through the antenna on the ground receiving stations, and the data which is collected here, that is rectified for different type of errors, and then it is made available for the users. So this part, यानी कि जो भी हमारा डेटा रिट्रीवल है उसको स्टोर करना एंड डिस्ट्रीब्यूशन करना, we have the space agencies and they mainly deal with this, and then it is made available in the form of the images or the electronic images, and we can use it for the different applications. Now this remote sensing is of two types: active remote sensing and passive remote sensing, depending upon the source of electromagnetic radiation. So if the sensor is recording the reflected and emitted energy, which is ultimately coming from the sun, then it is referred as the passive remote sensing, and the sensor which are used in this are referred as the passive sensor system. So in these two diagrams we can see that here we are having the energy source sun, and then whatever is reflected or emitted, that is recorded by the sensor which are placed on the platform. Now the active remote sensing is simply when on the platform itself we are having the source of illumination. So here you can see that we are having the source of radiation and which is illuminating a particular area, and then the amount of signal or amount of radiation which is scattered in the back direction, that is recorded by the sensors placed here. So in the case of active remote sensing, we are having the source of illumination or source of radiation on the platform itself. The radiation, it illuminate a particular area, and then the amount of reflected signal or the amount of reflected radiation in the back direction. So here we always use the term backscattered signal, because when the radiation is incident here, there is possibility that it may get reflected or it may get scattered in all the directions. But because the sensor is placed here only, so the amount of radiation which is getting reflected in the back direction, that will be recorded here. Now the intensity and the time of the backscattered signal is recorded by the sensor, and then it is used for different application. So simply the passive remote sensing is when we are using the sun as the source of energy, and the electromagnetic radiation coming from the sun, when it is reflected or when it is emitted from the earth, then it is recorded by the sensor. But in the case of active remote sensing, on the platform itself, we are having the source of illumination, and then this electromagnetic radiation, when it reaches to the earth, it will interact there, means it will again reflect back, and the time taken or how much amount of backscattered signal is there, it is recorded, then it is the active remote sensing. So example of the active remote sensing are the radar and sonar. So radar is the radio detection and ranging. So here we have the sensor which transmit the radio signal towards the earth or towards the target, and then it detects the backscattered signal. So depending upon the height of the object and the type of features on the earth, there will be variation in the time taken by the backscattered signal to reach back to the sensor, and the intensity will also vary. So when we are using the radio waves for the active remote sensing, it is referred as the radar. The second example is lidar. The full form is light detection and ranging. So here mainly the light in the form of the laser beams are utilized to illuminate a particular area, and then the amount of backscattered signal as well as the time taken by the backscattered signal to reach back to the sensor is noted, and again it has wide range of applications. So third is the sonar, that is sound, navigation and ranging. Here we mainly use the sound waves instead of the electromagnetic radiation. So this is mainly used in the underwater application because the sound, it travels much deeper in comparison to the radio waves and the light waves. We have the source of signal or source of sound waves placed on the ships, and then these sound waves are generated. When these sound waves travel or propagate in the water, depending upon the type of obstructions on which they are striking, they will reflect back. जो sensors हैं that can be placed on the platform itself, या फिर we can have the series of the sensors which are referred as the hydrophones. So the hydrophones, they receive the amount of back scattered signal reaching to them, and the time taken by the signal to reach back to the sensors or the each of the hydrophone, that is used to calculate the actual depth of these obstacles. So this sonar, it has wide application, ranging from for the fishing purpose or for the navigation purpose or for the estimation of the mineral deposits or the rock layers. In next video, we will learn about the interaction of electromagnetic radiation in the atmosphere. But उससे पहले, I request you to please go through the terrestrial radiation and the energy budget video. The link I have provided in the description box, because in that video we have discussed the short wave and the long wave radiation. So because जो next part है उसमें वो concept useful होगा आपको समझने के लिए, इसलिए आप एक बार please उस video को refer करें, and then we will again meet soon. Thank you.